Hello and welcome to this video. In this video, we will learn about logical operators and bitwise operators. But before we can learn those operators, we should learn about what is true and what is false in JavaScript. So consider a number 0. Is 0 true or false? So if you're coming from other languages, you would know that uh, 0 is false. So the way to test the the way to print the value or know the value of the truthfulness of a value is to apply Boolean function, and then we run this. So I have not saved. So it says it is false. What about a positive number 1? So 1 is true. So what about -1? So -1 is also true. So in general, whenever there is a value present, it would be true. And whenever a value will be absent, it would be false. For example, an empty string should be false. It is. But if you put in some value, it will become true. So we see numbers and strings are there. Booleans, there are two, true and false. What about undefined? We say it undefined. This should be false because there is no value. Now, how about null? Null should be false. How about nan? Nan should be false because there is no value associated with it. So it is false. Note that an array is always true even though it is empty. And similarly for a dictionary or map, this is also true even if empty. So be careful about that in JavaScript. Now, once we have this, what we can do is we can do or and not all those gates we can consider. So in case you don't remember those gates, I will quickly do it for you. So suppose there are two values, and gate is there. So we have 0 and we have 0, A and B. Then A and B would be 0. If both are 1, then it would be 1. And 1 is 0 and another is 1, then it would be again 0. So only if both are 1, the AND gate would be 1. In case of OR gate, we have OR gate A, B, and A or D. OR is written with a pipe. So in this case, 0, 0 will give us 0. 0, 1 will give us 1. 1, 0 will give us 1. And 1, 1 will give us 1. So the difference is AND gate is only true only if both the inputs are true. And OR gate is only false if both are false. Otherwise, it is true. So similarly, we have XOR gate. XOR gate is denoted by caret symbol. So as you might know, if both are same, it would be 0. If both are different, it would be 1. So this is how a XOR gate works. This would be 0. And then we have bit negation. Bit negation is, suppose we have 2, so its bits are 10. If you negate the bits, it becomes 0, 1. The bits are flipped. This is your tilde operator. This is bit flipping operator. Then we have NOT gate. NOT gate is reversal of value. If it is 0, it becomes 1. If it is 1, it becomes 0. That is your NOT gate. So we have covered 3 and 4 and 5 bitwise operations. Now let's see them in action. So if we say console.log 2 or 3, so what should be the output? Output should be true, but it is 2. Why it is 2 is the reason is it is short circuit evaluation. In a logical OR operation, if the first value which is true will make the entire gate true. So suppose we had 0, 2, 3. So when the compiler will see, when the code will execute, it will see 0 is false. So it will proceed further. It will say 0, 2 is true. So at this very moment, it will stop execution. It will not check for 3. So 2 is true. It will stop here and 2 will be returned. It does not even look at 3. The code won't. This is known as short circuit evaluation. Similarly, suppose we have 2 and 3. This is logical AND. So what happens in this case? In this case, it becomes 3. Why? Because AND operation cannot be short circuited. It has to go till the end of input. Because even if one of the inputs is false, then the entire operation becomes false. So either it will short circuit in one case if any of the values is false. But if in case of all true values, it will iterate through all of them. So logical OR operator, double pipe, will short circuit on first true value, and AND gate will short circuit on first false value. Similarly, you can test for integers, strings, and then we have not gate console.log, and we say not, we say some string hello, and we run this, and it becomes false because hello is true. So similarly, we can say console.log to, now we do bitwise. These are bitwise operators. The last row is bitwise. These are logical operators. Now we say 2 or 3. So what should be the output in this case? This will give us 2. Oh, sorry, 3. It is OR gate. So what happens here is 10 is 2 and 3 is 11. So when you OR 1 and 0, it becomes 1, and OR 1 and 1, it becomes 1. So the end value is 11 in binary. So you should be knowing the base 2 number system. So in this case, the output becomes 3. What if it is 2 and 3? It should be 2. So it is 2. We don't need this. What about bit negation? So suppose we want tilde 2. What should be output? I don't know. Can you try to guess? So it is -3. How come it became -3? So the answer lies in 2's complement. So you have a bit sequence like this. For example, there will be 53 bits. Now when you flip the bit, it becomes this. So in 2's complement, you have to find the negative number. So the most significant bits represents the sign. So you leave that, and you flip these bits and add 1 to that. That's what you do in 2's complement. So when you flip these bits, it becomes this. And then you add 1, it becomes 11. 11 is 3. So that's how bit negation works. Now we look at right shift and left shift. Left shift is multiplication by 2, console.log. Left shift is equivalent to multiplication by 2. So for example, 7, we shift it once, it will multiply by 2. So it will become 14. But if you shift it twice, it will get multiplied by 2 square. So it will become 7 into 4, 28. And similarly, if you do it 3 times, it becomes 8 times. So 56. Similarly, right shift is division by 2. Right shift is division by 2. So we shift it once. So half of 7 would be 3.5. So it will become 3. And you shift it twice, it will become 0. Oh, sorry, 1. 7 by 4 is 1. Yes. And you shift it 3 times, then it will become 0. So that's how left shift and right shift work. The triple right arrow is unsigned right shift. Okay. So it's the same for this case because both the numbers are unsigned. It will not operate on negative numbers. I don't think it should work. So it gave some arbitrary number. It does not work on negative numbers properly, that is. And the XOR gate, if you XOR say 10 and 0, 1, then it will become 3. So we see that also console.log 2 XOR 3, it should become 2 XOR 1, it should become 3. We have 3. So these are the basic gates which you should practice, and these will be useful when we do if else in our next video. This video I have finished the types, basic arithmetic, comparison, compound operators, logical gate, and Boolean gate. So when we will do larger programs, these gates will come into picture. So if you have not understood it clearly, I will recommend you to watch this video again or refer to the JavaScript ECMAScript manual, the specification. The specification of JavaScript is located in ECMA 262 PDF. So you can get it here. This is the specification of language and contains all the details. You can download or view in HTML. So if you view in HTML, you can read all this here. So it has all the operations related to JavaScript. So for example, I don't know operator behavior, so it should be in index. There is no index for that. Okay, so I don't remember where the operators are, but you can look at table of contents and you can probably know where the operations are there. So operations on, okay, this is something different. This is not operators. Anyway, state expressions, unary operators. This is where this should be. You see the tilde operator is here. And then we have equality operators. We have binary bitwise operators, the one I have talked about. We have binary logical operators. This coalesce operation I have not seen. It is bitwise or expression. Okay. And we have relational operators, additive operators. We have seen multiplicative, exponentiation, left hand side, and all that we have seen. Comma operator I have not talked about. I will talk about it later. And conditional also we have not talked about. Other operators we have covered. So you should try to read this. It is a very useful book. Not book, it's specification. But it will be difficult to understand it because there are no examples. Specifications are meant for people who implement compilers and interpreters. So it may not be very useful to learn the language, but as a reference, it is very good. Once you learn the language, you can read it for the sake of completeness. So I'll stop this video here. I hope that you have found this video useful and informative. So thanks a lot for watching. Happy programming.